Here we have a goal box, so an automotive grade central or zonal PC, where we have our virtual sensor for tire and brake temperature running on it. So here is the config. Normally data are fed from the car via CAN bus. Here for this demo we choose to have some sliders from the UI so the user can directly interact with it. Then we use a data broker, which is the central piece to provide information or signal to both the virtual sensor and the UI. So as soon as I change something, I provide this data in a standardized way using VSS to the data broker, and the virtual sensor are using this information. Then we wrote back to the CUXA data broker new signals with the temperature, and this signal can be used anywhere in the vehicle. And then you don't even know if it's coming from a hardware sensor or a virtual sensor. You just use this information. So concretely, this is virtual sensor in action on automotive grade hardware, really working. You can see, for example, now the car is driving by 40 km/h. And let's imagine that I make some regeneration. So like an electric car, what you see is you put some stress on your tires so the temperature will raise, but not the temperature from your brakes, because you are not using your mechanical brakes. Then I put basically the acceleration again to zero, almost zero, and you see your temperature dropping because you have less load on your tires. But now let's imagine that I'm braking. Here for this demo, I really assume that I keep my speed constant. It's like I'm accelerating and braking at the same time. Now I'm braking and you see directly your temperature of your brake pad and brake disc, which is rising. This is normal. And here you see that the virtual sensor are really reacting correctly. This is a model, this is virtual sensor that we validated on some car and running live on an automotive grade hardware.